this video, we will learn about electricity. In this chapter, you will explore the fundamental concepts that how electrical circuits work. As you all are familiar with the flow of electricity through an electric circuit, you will begin by revising some key terms like potential difference, electric current, then electric resistance. This chapter will introduce some new concepts such as electric power and electrical energy. Then we will explain their importance and how they are actually measured. By the end, you will be able to calculate the electricity consumption of various appliances that are present in your homes, like the consumption of electricity done by fan, AC, that is air conditioner, or other appliance, etc. Students must know the elements of household electric circuit with a special emphasis on certain precautions and using of safety devices so to protect themselves and others against electrical hazards. So the first term is electric current. So what do we mean by electric current is simply the speed of charge, or we can say actual definition is the rate at which the flow of electric charge has been taken place in an electric circuit. So suppose we have a total amount of charge which is Q that is flowing in a circuit at a time T. Then we can say that electric current is simply equal to I is equals to Q divided by T, and its SI unit is ampere, which was named after the name of scientist known as Andre Marie Ampere. Now let's talk about what is the direction of electric current. So suppose this is an electric circuit and we know that basically electron will flow in this direction because electron will be removed from here from the negative terminal, then electron will be moved in that direction. We know what is the magnitude, or basically what is the sign of charge on electron. Electron is negatively charged, so the direction of current will be opposite to that of the electron. So the direction of current will be in this direction only, that is opposite to that of negatively charged particle. So here it is mentioned that the direction of electric current is taken as the direction of flow of positive charge or opposite to the direction of flow of negatively charged particles in a circuit. So this is going to be our direction of the current in this direction, from positive to negative. And for electron, it will be negative to positive, or any negatively charged particle will move from negative terminal to positive, whereas a positively charged particle or electric current will flow from positive to negative terminal. Then we have something called as cell. So cell is simply, we just saw this is one is cell. Cell is the simplest and the most basic device, and whereas this is the battery, which is actually the combination of multiple cells. So when we have multiple cells, we combine with them, we will get basically a battery. So a cell or a battery which is composed of multiple cells, it is the simplest and most basic device used to maintain the electric current flow in a circuit. So in a circuit, electric current flows from positive terminal to the negative terminal of the cell, as we just saw in the last diagram. Then we use an ammeter. So ammeter is simply a device which is used to measure the amount of current flowing through it. So suppose if in a circuit there is some current flowing, we'll put the ammeter there and we'll calculate, we will able to see how much current is actually being flown in that circuit. Suppose the answer could be 2 ampere, 3 ampere, etc., depending upon the current. Now what do we mean by electric potential difference? Suppose we have 2 points. Now here is a charge Q is sitting. Now I am moving this charge particle into the point B. So for moving this charge particle from A to B, I have to do some work. Now the work done which I have done, let us suppose that to be W. So the work done divided by the charge is simply my potential difference. So what do we mean by potential difference? It is basically, it is some first of all given between 2 points in an electric circuit, and it is defined as the amount of work done for moving a unit positive charge between these 2 points. Suppose the value of Q is basically 1 coulomb, that is unit positive charge. Then what will be the work done? Then work done will be simply equal to V. So that's how we define this. So if W is the amount of work done for the flow of Q charge from one point to another, then potential difference is going to be V is equals to W upon Q, and its SI unit is volt, which was named after the name of the scientist Alessandro Volta, who devised the first electric cell. So as the unit of potential difference is volt, we usually refer potential difference as voltage. So generally we say in our homes as well that voltage is down or voltage is up. That is just because of potential difference only. Then the voltage of an electric cell, or the potential difference, is the difference between positive and negative terminals of the cell. So positive charge flows from, we just saw, high higher potential, which is positive terminal of the battery, to negative terminal of the battery. Now for calculate current, we use a device called as ammeter, but to calculate the potential difference, we will use a device which is said to be voltmeter. Then the next concepts are resistance and resistor. So we know that in metals, or in any metal, there are electrons flowing through it. So whenever we apply current, we basically put a battery around them, they start flowing in a single direction, and the current will, and we'll see some current. But in each and every element, there is something which is resisting that current. So that property is simply called as resistance, and the material which is doing so, that is said to be resistor. So any element in an electric circuit which causes the restriction or resistance for the flow of electric current, that is said to be resistors. Example, we have electric bulb, fluorescent tube, CFL, electric fan, electric heater, geyser, and electric mixer grinder, etc. These are some of the common examples of resistors. And this obstruction or resistance or restriction by an element for the flow of electric current, this is said to be the property which is known as electric resistance of that element or resistor. So resistors shows resistance for the electric current, and electric resistance is usually denoted by the symbol capital R. Then it is found that if we have a voltage V across a circuit element which is resistor, and we see that the current is flowing through it whose magnitude is I ampere, then the resistance can be simply written as R is equals to voltage divided by the current. The SI unit of electric resistance is ohm, which is named after the name of the scientist Sir George Simon Ohm. Then electric resistance is said to be 1 ohm if we have the value of potential difference 1 volt and we have the value of current is 1 ampere. Then simply we know 1 by 1 is simply 1, so the value of resistance is going to be 1 ohm. So if a potential difference of 1 volt is required to maintain a flow of 1 ampere current. I hope it is clear to you. Thank you.